In organic chemistry, you will see loads of diagrams that look like this one on the left. You've got a couple of chemicals or a couple of different species, and then you've got these curly arrows drawn around them. Those curly arrows essentially tell you what is going on with the electrons. Where are the electrons going? Where are the electrons coming from? What are the electrons doing? By understanding what the electrons are doing, you understand what is going on chemically. Therefore, these curly arrows are vital in organic chemistry and representing how mechanisms work. And they are basically the crux of a reaction mechanism. Therefore, it's really important that you use them correctly. And even if you understand what a reaction mechanism is and how a reaction mechanism is happening, if you can't display that using curly arrows, you will lose marks, and that's not something we want. So first of all, let's think about what a curly arrow truly is. So we'll draw a nice simple one here. The curly arrow just tells you the movement of a pair of electrons. And we know it's a pair of electrons because if you look at the end of the arrow, the actual point, it's got 2 bits on the point. So that tells you it's a pair of electrons. You can have a half-headed arrow, that just tells you it's 1 electron, but virtually all the reaction mechanisms will do, except for the free radical substitution and homogeneous fission, will do the double-headed arrow. So if it tells you the movement of a pair of electrons, that means the arrow must start from where the pair of electrons is. So if we think about possible places where an electron pair can start, it could be a lone pair of electrons, because a lone pair of electrons is a pair of electrons. It could be a covalent bond, because a covalent bond is a pair of electrons. And these are the most common places where a pair of electrons will start from, and therefore they're the most common places a curly arrow will start from. When you get into the second year and you start doing aromatic chemistry, you could also have the delocalized ring. But that's not so essential for you at the moment. Now, therefore, the other end of the arrow tells you where the electron pair has moved to. So if you think about where can an electron pair move to, well, it can move to somewhere to form a bond. Or it can move onto an atom. And they're going to be the 2 main places where we're going to have our curly arrow actually ending. So if we look at the diagram on the left, the bottom curly arrow is moving from the lone pair on the hydroxide and it's moving to a carbon. So it's starting from a lone pair, that's good. It's ending at an atom, there are both bond formed, that's good. The second curly arrow between the carbon and the bromine, it's starting from a bond, covalent bond, that's a pair of electrons, that's good, and it's moving to an atom. So that's fine as well. Now, you just need to remember, whenever you draw a curly arrow, is it moving from a lone pair? Is it going to an atom or where a bond is formed? So just some common mistakes that people make. These are just different ways that some people might draw a hydroxide. So let's say I start with this hydroxide and I go like that, and we'll pretend wherever the arrow is going from is, or wherever the arrow is pointing to is the correct place. So this first example, I would get no marks. because there is no lone pair. And I haven't shown that the curly arrow is moving from a lone pair. If I've got this second one, I've drawn the lone pair on the oxygen, but my curly arrow isn't going from the lone pair. I'd also lose a mark from that. So even if you draw the lone pair, the curly arrow has to start from the lone pair. Maybe you've drawn it in the right place like this, and you put the lone pair in a sensible position where you normally would, but then you draw the curly arrow coming from up here. Again, you wouldn't get the mark because it's not coming from the lone pair. So they're really easy ways to lose marks. Now, let's go into some other ways people can lose marks on these questions, because there are lots. So now let's assume that you're going to draw your hydroxide correctly, and then we'll come on to our bromoethane. Let's say you get lazy and draw that. So you're trying to get the arrow to point to the carbon. To me, that looks like that's pointing to the bond, so you would lose the mark. If we try another one, and let's say you're in an exam, you're rushing and you just do that. So you're going to try and get it pointing towards the sea, but you finish short. That would also be wrong. It's not pointing to anything. And they will be really picky in the exam about how they're marking this. Now, the second curly arrow, some people quite often will draw this because you think the electrons are now going from the carbon to the bromine. That's wrong. Because it's not starting from the bond. The carbon doesn't have a lone pair, so it can't move from that. Don't know why I managed to get that to a rainbow pen. That's exciting. Or maybe you'll get excited and you'll think bromine has a lone pair. So maybe the electrons are going to that. Again, that would be wrong. It's starting from the wrong place. So it has to be pointing in the correct direction as well. So make sure that it starts from a lone pair or a bond, always. Make sure it's pointing to wherever the bond is being formed, normally an atom or where another bond already is, because then it can form a double bond. Now, let's just show you, because we know that AQA are liking this a little bit more recently. Let's draw a skeletal diagram. And now let's draw our hydroxide ion. Where's our curly arrow going to go? Well, it has to start at the covalent bond. We want it to point to the carbon, so make it really, really obvious if you're drawing a skeletal diagram that you're pointing to the carbon. Make sure it's absolutely obvious that you're pointing to the point. You point to the apex where you get the zigzag in the skeletal diagram, because that's where the carbon is. Make it really obvious that that's where your arrow is pointing. When you're doing skeletal diagrams, sometimes it's harder to make it really obvious where it's going. And for the second arrow, make sure it's obviously between carbons, so it's at a bond, and then it's obviously pointing to the bromine. And let's say that you're not using the hydroxide this time. Let's say we're going to do another nucleophile. Let's say ammonia. When you draw the mechanism, even though when you write ammonia in the equation, you just write NH3. When you draw the mechanism, make sure you draw the lone pair. Because if you draw that lone pair, then when you draw the curly arrow, it can obviously be moving from the lone pair. If you don't draw the lone pair onto the ammonia, your curly arrow won't obviously start at a lone pair. They wouldn't give you the marks. So for now, that's the basics behind the do's and don'ts of a curly arrow. Make sure it starts from a lone pair or a bond, basically a pair of electrons. Make sure it points exactly to where you want it to point. Don't just have it roughly there. There can be no possible dispute. This isn't some kind of random offside decision in VAR or VAR in football. It has to be 100% definitely pointing to the correct place. Be careful when you draw curly arrows. You will lose marks unless you are so precise.